Hello, in this lesson we are going to talk about SSH, one of the most important tools in Linux. With SSH, you connect to a remote server, work in its terminal, copy files and set up access. And today we are not going to stay only with theory. We will go step by step and do everything in practice. We will connect to a second virtual machine, create a key, set up passwordless login, understand fingerprint, and then copy files with SCP and RSYNC. So the goal of this lesson is simple. After this video, SSH should not feel like something strange or abstract. It should feel like a normal everyday tool. SSH is a way to connect safely to another computer through a network. Usually, that other computer is a server. So, I am sitting at my own computer. I open the terminal and I can enter the terminal of a remote machine. Let's show that right away. For this example, I have a second virtual machine. The username there is Alex, the machine name is server, and the IP address is 10.0.2.15. For example, if I type SSH Alex and IP address, I am trying to connect to the remote machine as the user Alex. Let's run this command. If this is the first connection, the system may show a message saying that the host is not known yet. That is normal. In a moment, we will talk about what that means. After that, the system may yes, of course. After that, the system may ask for the password of the user Alex on the remote machine. If the password is correct, we get inside. And now let's check where we are. pvd and hostname. Now we can see that the commands are running not on my local machine, but on the remote one. And the hostname command shows the name server. This is a very important habit for a beginner. Always understand where you are working now, locally or already on the server. Password login works, but in real practice, people usually use keys. So, now let's set that up. To connect in a safer and more convenient way, people usually use SSH keys. The idea is simple. We have two keys. One is private, it stays with us. The second is public. We can put it on the server. Let's create this pair. Again. Usually, for the first demo, it is enough to run the command without extra options. The system will ask where to save the key. Most people just keep the default path. Usually it is inside the SSH folder. Then the system may ask a passphrase. This is an extra password for the key itself. For this demo, I will skip it, just to keep the first example simple. Now the key is created, and we can look at what appeared in the folder. LR. Yep. Usually you will see two files, this and this. The file without pub, it's a private key. This is our private key. You should never give it to other people. The file with pub, this, it's public key. That is the one we will add to the server. And now the next step is very logical. We need to make the machine, our server, accept this key. For key-based login, the server uses a special file, authorized keys. Public keys that are allowed to login are added to this file. So the server checks this. If you have the correct private key, then you can log in without the normal password. We already created a key pair. And if we want, we can look at the public key with the command cat ssh pub. It's our public key. But now we are not going to copy it by hand. There is a more convenient command for that. ssh-copy-id. Our machine. Let's run it. Yep. The command connects to the remote machine and automatically adds our public key to the file authorized keys for the user Alex. Most likely I will need to enter the password one time. That is normal. Right now we are not logging in without a password yet. We are only setting it up. After that, we can test the result right away. SSH Alex 15. Yep. If everything is correct, the login should now work without the normal password. So, what did we do here? We created a key pair, sent the public key to the remote machine, and set up a more convenient SSH login. And now is a very good moment to explain one more thing that beginners almost always see during the first connection. That is GNOME hosts and fingerprint. Let's go back to the very first connection. When I first time ran command for connection, SSH and IP address, SSH showed a message like this: the authenticity of host cannot be established. And then it showed a fingerprint. This is a very important moment. The server also has its own key, and SSH shows a short form of that key. This short form is called a fingerprint. In simple words, SSH is asking, are you sure you trust this machine? If you confirm the connection, the information about that server is saved in the file GNOME hosts. So, GNOME hosts is a list of hosts that are already known to you. Let's look at that. SH GNOME hosts. Yes. And there should already be an entry for our server. Why is this needed? So that during the next connection, SSH can check that this is still the same machine and not some different machine. If the server key changes, SSH will warn you. Sometimes that is normal. For example, maybe the virtual machine was recreated. But sometimes it is a reason to stop the check what is happening. So, for a beginner, the main thing to understand is this. Fingerprint is the short form of the server key, and GNOME hosts is the list of servers that you have already trusted once. And now let's move on. We already have a key, passwordless login. Is it set up? and we can make the work even more convenient. Sometimes the key has a passphrase, or maybe you just do not want to type the path to the key every time. For that, people use ssh-agent. Ssh-agent keeps keys in memory during the current session, and ssh-add adds a key to that agent. Let me show it. ssh-add and our key. Our key. Yep. After that, the key is loaded into ssh-agent, and SSH can use it automatically. For a beginner, the main thing to remember is this simple pair. ssh-keygen creates a key. SSH adds the key to the agent. And now, when the connection already works, let's move to the next practical task. Very often, after SSH, you need not only to enter the server, but also to copy files there. For quick copying through SSH, there is the SCP command. If we say it very simply, it is almost like CP, but between two machines. Let's first send a file to the server. For example, if I type this command, this means take the local file txt and send it to the remote machine into the home folder for the user Alex. Now, let's show the opposite direction, how to download a file from the server to our machine. We use command scp alex home Alex file txt. The dot and the end means the current local folder. So SCP is good when you need to quickly move one file in the one direction or the other. If you need to send a folder, people usually this option. cp -r, for example, my dear Alex. That's it. Home Alex. Here, -r means recursive copying of the whole directory. SCP is useful mainly because it is simple. But when there are many files, and especially when you need to run copying many times, RSYNC is usually more convenient. RSYNC is a more flexible tool. It is especially useful when you copy folders, projects, or regularly update files on a server. For example, if I have a local folder called site, I can do this. Here, -a means archive mode, -v means verbose output. In practice, this is very useful because RSync usually sends only changes, not everything again from the start. And in this way, I synchronize the contents of the local folder with the remote folder on the machine server. There is one more practical thing here. The slash at the end of the path can change the meaning. Site slash usually means copy the contents of the folder, and just cite more often means copy the folder itself as an object. For the first lesson, it is enough just to remember this and be careful. So the rule is very simple. If you need to quickly send one file, use SCP. If you need to regularly synchronize data, use RSYNC. And now, when we already have several commands, let's make the work easier. When you already have several servers, long commands quickly become annoying. So it is very useful to use the file ssh-config. Let me show the smallest useful example for our machine. You can put this block in this file, and after that, instead of the long command ssh alex IP address, you can write simply ssh server. Yep. And this really makes life easier. The same thing also works for SCP and RSYNC. SSH will take the settings from config file by itself. This is a small topic, but in practice it is very useful. And there is one more thing left that often breaks the connection for beginners. That is permissions on SSH directory. Sometimes everything looks correct. The key is there, the server is reachable, the command looks correct, but SSH still says permission denied. Very often the reason is the permissions on the SSH folder or on the key itself. SSH is very strict about security. If the private key is to open, SSH may simply refuse to use it. So here the important idea is very simple. The SSH folder should belong to the user and should not be too open. The private key should also be available only to its owner. If the permissions are wrong, you may see errors like permission denied or bad permissions. So sometimes the problem is not in the network and not in the server. Sometimes the problem is simply that SSH does not like the file access settings. So if the connection does not work, it makes sense to check. Does the SSH folder exist? Does the correct key exist? And are the permissions not too open? And at this point, we already have the full basic picture. We connect to server, set up keys, trust the server, copy files, make commands shorter with config, and understand one common reason for permission denied error. In this lesson, we connected to the machine through SSH, create a key, set up passwordless login, and saw how to copy files with SCP and RSYNC. We also talked about fingerprint, no hosts, and the config file. And we also understood why SSH sometimes says permission denied because of permissions on SSH. This is the end of our basic Linux course. Next, we will study Linux in more depth and more professional topics from real practice. See you on the next lessons.